All right, hello. Let's see. I'm trying to figure out. Here we go. All right, doing number 53, I believe. 53, and that refers back to 51. And so I'll be sliding my book into here as I'm talking about it. Um, it says find the mean and standard deviation of the difference y minus x. Um, in the number of errors made by a randomly selected student. Interpret each value in context. And Y is the number of word errors, which is the second table underneath number 51. And X is non-word errors. Okay, so find the mean and the standard deviation. Oh, I should have written these down in advance. Sorry. So mu sub Y, sigma sub Y, mu sub X, sigma sub X. Let me get those written down real quick. So the Y's are 1.0 and 1.0. Whoops. 1.0. And the X's are 2.1 and 1.136. And this, again, came from exercise number 51. So mu sub Y minus X, again, remember this thing about means. They're pretty user friendly. So 1.0 minus 2.1 is negative 1.1. And there is our difference in the means. That's the answer to the mean. And here it is in context. I'm not going to write it down, so you're just going to have to listen to this. If you were to select many essays, there would be about 1.1 fewer word errors than non-word errors on average. And again, get good at interpreting means and standard deviations. Here comes the standard deviation. Actually, here comes the variance first, and then I'll convert it to standard deviation by taking the square root. Okay, and so the variance of y is 1.0 squared. And then remember, here's the key thing, plus 1.136 squared. Remember, there will be a lot of good students that think, oh, I'm subtracting, so I subtract. You always add variances and then take the square root. So I'm going to go ahead and take the square root here too. Do it all on my calculator in one quick shot here. So let's see. So doing it on my calculator and then taking the square root, we should get that the standard deviation is 1.51. Okay, so make them variances by squaring, add them together, and then square root to calculate the standard deviation. And my notation here is a little bit wrong. I think I probably should lose that squared because I square rooted there. Okay, so it depends on how you want to do it. And I think I just kind of goofed up a little bit. So here's my interpretation now, the very important interpretation piece. The difference in the number of errors will typically vary, there it is again, by about 1.51 from the mean of negative 1.1. Okay, and so that's your interpretation that you need to be good at doing. And then part B is an interesting little question. It says, in part B, it says, find from the information given, can you find the probability that a randomly selected student makes more word errors? And again, that's the bottom table if you're looking at number 51. If so, find this probability. So more word errors than non-word errors. So what would that look like? Well, the outcomes would be, and again, word errors has to be bigger than non-word errors. So 1 minus 0 would be an outcome. So again, if you look at where I'm getting this from, when my 0 is equal to 1, I should finish that thought. If you look at the table, I want to know where these are bigger than these. Okay, so 0 is not bigger than down here. It's not bigger than any of the values up there. So I'm not interested in that. 1 is only bigger than 0. So 1 minus 0, because remember, I'm doing the difference. Okay, another possibility would be 2 minus 0 and 2 minus 1, because we're doing the difference. 2 minus 0 is equal to 2. 2 minus 1 is equal to 1. And then what else do we have? Well, we have all the possibilities with three word errors and the non-word errors. So 3 minus 0, 3 minus 1, 3 minus 2. And those are all the instances where these numbers are bigger than those numbers. Okay, so 3 minus 0 equals 3, 3 minus 1 equals 2, and then 3 minus 2 is equal to 1. Now here's what I need to do. I need to find all the probabilities. Oops, I didn't know that wasn't on the screen there. Sorry. I need to find all the probabilities of these outcomes happening. I'll show you how to do 1 minus 0 and 2 minus 0, then we'll write the rest of it in. Okay, so 1 minus 0, here comes the book again. 1 minus 0, the probability of 1 is 0.3. The probability of 0 non-word errors is 0.1. And how do I get that outcome? That times that. Okay, and that was explained in some other question that we had earlier. I don't remember exactly what it was. So 0.3 times 0.1 plus, and then we're going to add all these probabilities together. So how about 2 minus 0? So 2 minus 0, 0.2 times 0.1. So 0.2 times 0.1 plus, and then I'm going to do them pretty quickly. So 2 minus 1 would be 0.2 times 0.2, or 0.2 squared, plus, and then the next one is, let's see, what have I done so far? This one, this one, this one. How about 3 minus 0? So the probability of 3 is 0.1. The probability of 0 is 0.1. So that'd be 0.1 squared. I'm running out of room over here. Plus 3 minus 1. The probability of 3 is 0.1. And the probability of 1 is 0.2. Plus, and then the last one is 3 minus 2, so 0.1 times 0.3. 0.1 times 0.3. And let's figure out what that equals. I'm going to cheat right now and look at the answer. The answer says 0.15. Okay, and I think we have to interpret too. So but hang on, I want to make sure that I get 0.15 and I'm not leading you astray. So I have 0.3 times 0.1 plus 0.2, I want you to follow where I'm doing this. 0.2 times 0.1 plus 0.2 squared plus 0.1 squared plus 0.1 times 0.2 plus 0.1 times 0.3 equals, and I get 0.15, which is the correct answer. Now, do they ask me to interpret, or what they ask me to do? If so, find this probability. If not, explain why not. So here's my explanation. There is a 0.15 probability that a randomly chosen student will have more word errors than non-word errors. So that's it. That's all I need to do. So take a look at the tables to see where these numbers are coming from. You have to look at those two tables in the question. And then all this is all the instances where the non-word errors are greater than the word errors. That's why I made this little list, and then I calculated the probabilities off that list. Hope that makes sense and hope it helps. I don't think you'll see a question like this on the test, but absolutely you will see a question like that one on the test. Okay, guaranteed. And I tell you what, the main thing I want to make sure that you guys get, just hint, hint, hint. Can you do that? Do you see that it doesn't matter whether you do the sum or the difference? Do you understand that you have to add the variances to calculate your new standard deviation? But don't worry so much about getting this. This is not something that I think you're going to see as a topic being tested upon. All right, thanks for asking.